All right, today we're jumping into some really fascinating research that shows how AI can basically act like a detective, sifting through millions of data points to find strange and hidden patterns in how we move.
So think about this for a second. This is the huge challenge that a team of researchers decided to take on. You've got this massive digital ocean of information. We're talking over 100 million data points. How in the world do you find that one tiny ripple that tells you something truly unusual is happening?
So first up, let's talk about the mission itself, the search for these unusual patterns. Because this isn't just about playing with numbers, it's about what those numbers can tell us about the real world and why finding that odd one out is so important. And this is where it gets really interesting, because the real-world uses are massive. Imagine if you could spot these movements to help authorities get ahead of security threats. Or for businesses, they could create way smarter marketing campaigns because they actually understand how crowds behave. And maybe most incredibly, it could even be a tool for public health, helping us spot the very beginning of something like a pandemic. Okay, but here's the thing. Why is this so hard to do? Well, it all boils down to one huge problem, the messy data problem. The researchers were using real-world info from mobile phones in Hiroshima, Japan, and, well, let's just say the data they had to work with was a total mess. And to give you an idea of the scale we're talking about, just look at this number. Over 112 million raw data records. That's what they started with, from just a single year. That is a mind-boggling amount of information to try and sort through. So you can't just, dump this into an algorithm and hope for the best. The data set was, for all intents and purposes, a messy crime scene. You've got duplicate observations, data points just gone, missing timestamps, things entered inconsistently. It's like being a detective with smudged clues and whole pages just ripped out of your notebook. So, how on earth do you solve a problem like this? Well, their solution was pretty ingenious. They built what's called a multi-agent system. You can basically think of it as putting together a highly specialized digital detective squad, where every single AI agent has its own specific job. And the way this squad works is absolutely critical. It has to happen in order. First, you send in the cleaner agent. Its only job is to tidy up the scene, fixing formatting and getting rid of duplicates. Then, the forecaster agent comes in to intelligently fill in all the missing pieces. And only then, once the scene is all prepped, does the lead detective get to work, analyzing the now clean data to actually hunt for those strange events. Okay, so we've got our team of AI agents. Now let's see how they actually get the job done. How does this investigation really work in practice? So that forecaster agent, its job is to fill in the blanks. And it doesn't just, take a wild guess. Nope, it's way smarter than that. It actually tested out a bunch of different methods to see which one was the most accurate. And just like any good detective, it went with the tool that had the lowest error rate. In this case, the boosted decision tree. All right, so the data is clean, the gaps are filled. Now the lead detective takes over, and it uses this really cool technique called STL decomposition. It's an amazing way to think about data. It's like taking a piece of music and breaking it down into its three secret parts: the long-term trend, the predictable seasonal rhythm, and then everything else, the leftovers. And the real clues? They're almost always hiding in those leftovers. So what is an outlier then? Simple. It's a data point, hiding in that leftovers pile that's just way outside the normal, expected pattern of activity. These are the weird moments, the unexpected spikes that our AI detective is built to find. Okay, so the stage is set. The data's been cleaned, corrected, analyzed, the whole shebang. So what did this AI detective squad actually find in the city of Hiroshima? Let's take a look at what they uncovered. Get this. Just looking at one single spot, Hiroshima Station, look what they found. Depending on how sensitive or, how picky they made the system, they found anywhere from 4 to, wait for it, 159 totally unique, unusual events over that 1 year. And this right here is the big payoff. What you end up with is basically a heartbeat monitor for the entire city. The AI can see the normal rhythm of a Tuesday. It can see the big, predictable spikes for holidays. But most importantly, it makes the truly weird moments stand out clear as day. It's like it automatically puts a big red flag on any spike in movement that just doesn't fit in. And here's what's so incredible about this. The system was smart enough not to get tricked. It could see the big crowds for holidays and go, yep, that's normal. Nothing to see here.
It was able to look beyond that predictable noise and still find other, genuinely strange events that were happening at all kinds of different times. That is a huge deal. So, at the end of the day, what we have here is a brand new tool, a powerful new way to listen to the rhythm of our cities. It can see the normal and highlight the abnormal, which leaves us with a really big question, right? If AI can get this good at spotting the weird patterns in how we move, what should we ask it to look for next? Where do we point this powerful lens?